DeepSeek's advanced AI and data-driven technologies can significantly benefit the metal forming sector by addressing critical challenges and driving innovation. Here's how. 1. AI-driven process optimization. Predictive modeling. DeepSeek's AI can simulate metal forming processes, e.g., stamping, forging, extrusion, to predict material behavior, stress distribution, and potential defects, enabling optimized tooling and process parameters. Energy and cost savings. Machine learning algorithms can minimize material waste and energy consumption by fine-tuning parameters like temperature, pressure, and forming speed. 2. Enhanced quality control. Defect detection. Computer vision systems powered by DeepSeek's AI can inspect parts in real time for cracks, warping, or dimensional inaccuracies, reducing scrap rates. Predictive quality analytics. AI models can correlate process variables, e.g., lubrication, tool wear, with final product quality, allowing proactive adjustments. 3. Predictive maintenance. Equipment health monitoring. By analyzing sensor data from presses, dies, and molds, DeepSeek's AI can predict equipment failures before they occur, minimizing downtime. Tool life optimization. Machine learning can forecast die wear patterns, recommending optimal maintenance schedules to extend tool lifespan. 4. Material innovation. Material selection guidance. AI can recommend advanced alloys or composite materials tailored to specific forming requirements, e.g., lightweighting for automotive applications. Formability analysis. Deep learning models can predict how new materials will behave under forming stresses, accelerating R&D for novel alloys. 5. Digital twin and simulation. Virtual prototyping. DeepSeek's digital twin technology can simulate entire production lines, reducing the need for physical trials and shortening time to market. Process validation. Real-time simulations validate forming processes for complex geometries, e.g., aerospace components, ensuring feasibility before production. 6. Supply chain and inventory optimization. Demand forecasting. AI-powered analytics can predict market demand, helping manufacturers optimize raw material inventory and production schedules. Resource allocation. Smart algorithms streamline workflows by balancing machine loads and prioritizing high-value orders. 7. Sustainability improvements. Waste reduction. AI-driven process optimization reduces material overuse and scrap. Energy efficiency. Machine learning identifies energy-intensive stages in forming processes and suggests greener alternatives, e.g., cold forming over hot forming. 8. Workforce training and support. AI-assisted training. DeepSeek's tools can provide real-time guidance to operators, improving adherence to best practices. Troubleshooting knowledge bases. Generative AI chatbots can offer instant solutions for common issues, e.g., springback correction, lubrication problems. 9. Open source collaboration. Customizable solutions. Open source AI frameworks allow companies to adapt DeepSeek's tools to niche applications like microforming or high-precision aerospace parts. Community-driven innovation. Shared tools and datasets foster industry-wide advancements in forming techniques and standards. 10. Competitive advantage. Faster innovation. Rapid prototyping with AI reduces development cycles for new products. Agility. Real-time data analytics enable quick adaptation to market shifts, such as demand for electric vehicle components or sustainable packaging. Example use cases. Automotive stamping. AI optimizes blank holder forces to prevent wrinkling or tearing in sheet metal. Forging process. Predictive models adjust hammer strokes in real time to ensure consistent part density. Additive hybrid manufacturing. DeepSeek's AI integrates additive and subtractive processes for complex metal parts. By integrating DeepSeek's technologies, the metal forming sector can achieve higher precision, lower costs, and faster innovation cycles, positioning itself at the forefront of advanced manufacturing.